Hello everyone, welcome to my channel. Today we shall see a very interesting topic in database management system, the ER model. Now, before we embark on ER model details, let's ask few questions. Why modeling is required and what is a model and how the modeling is carried out. So first thing is why we require modeling. So whenever you want to develop a software, you have a team of people who are all technical guys who know database, who know SQL queries and all. But you'll be building an application in some other domain, let's say in banking domain. So you need to understand the terms that are used in that domain and accordingly extract what are the requirements of that particular software. Similarly, it could be an insurance domain or it could be a automobile domain. So we need to have domain knowledge and we should be able to communicate with the stakeholders, especially the end users who ultimately use your software. Picture is worth 100 words. So if you can pictorially depict the requirements of your application, so the end users will be able to connect to us very quickly and will be able to accurately extract the needs of the software, especially the data requirements of the software and also the functional requirements of the software. So ER model is a graphical method of visualizing the data in a given application domain. So the need for modeling is to effectively communicate with end users and extract data requirements for building the software. Okay. Now, next thing is what is ER modeling? Okay. So before that, we see what is a model. So model is a set of concepts that help describe the data in the given application domain. So basically it is a set of concepts. So I am underlying the term set of concepts here. Okay. So we need to understand that there are certain set of concepts which will help me describe the data in the given application domain. All right. So how modeling is done? We shall see there are certain set of notations and if we understand the meaning of each one of them, we will be able to come up with a nice model which will help extract the data requirements of the software being developed and also communicate to the end users uh, visually the requirements of your application. All right. So in ER model, what are the concepts? So we need to look at what are the concepts. All right. So as we all know, ER model is a set of concepts. So the concepts here are entity is the first concept that we need to understand. Then there is a concept called as relation. We have attributes. We have cardinality ratio and participation constraints. Now these are the 5 concepts that we use to describe our data. So entity, how do I define entity now? So entity is a thing which is either conceptual or real and has unique identity. Unique identity. Now, what do we mean by conceptual or real? For example, we know that account in a bank is a concept. We cannot see it, or we cannot touch it, or with our, we cannot feel it. But it is a concept very important to understand how the banking happens. It's a conceptual thing. On the other hand, if you take student as an entity, it's a real entity. We can see him, we can touch him. So it is a physical existing entity. Even a computer is a real entity. And unique identity it must have. So every student is unique, right? Similarly, every account has a unique account number. So uniqueness is very, very important. So anything which does not have a unique identity cannot become a entity. All right. So we encounter a lot of entities in a given application scenario. We shall see through an example how an entity uh, can be described using the notations, and also how one entity is related to another. So next thing is the concept of relation. So relation is how one entity is related to another entity. For example, a student belongs to department. All right. Similarly, the project is controlled by the department, or an employee has dependent. So we see there are entities which are related to one another. So a relationship allows me to associate one entity with another in more than one way. Then attributes. What are these attributes? So entity, as we know, is a real or conceptual thing. So how do I describe an entity? So to describe an entity, we have attributes. Okay, so attributes basically describe the entity in more than one way. For example, a student may have an attribute USN. He may have first name, last name, semester, department number to which he belongs to. So attributes help you describe the entities in a more detailed way. And attributes again come in many different forms. So there is a key attribute, then there is a simple attribute, then there is derived, multi-valued, composite, and complex. So these variations we shall see through an example. What is a key attribute? What is simple attribute? What is derived attribute? What is multi-valued attribute? And what is composite attribute? So all these details we shall see in a given application scenario. Similarly, the next concept is cardinality ratio. So there are three different cardinality ratios: 1:n, 1:1, and many to many. Of course, n is to 1, 1 is to n, they are one and the same. Just that left hand side become right hand side and right hand side becomes left hand side. So how many on one side are related to how many on the other side? For example, a student might have enrolled for many courses, so it is 1:many. Similarly, a department will have only one HOD, so one employee will be HOD of one department. Many to many, we have numerous examples. For example, a customer may have many accounts, and accounts may be shared by more than one person. So we have a many to many relationship. So we have coordinate ratios, and this concept is very, very important whenever you are doing mapping from ER model to relational model. Remember, ultimately, ER model is only for illustrative purpose and extracting the data. Once that model is ready, you have to ultimately convert it into relational model, which database management systems understand. So while converting ER to relational model, these coordinate ratio become very, very important. The next thing is participation constraint. How many entities are, if all of them are participating in the relation, then we call it as full participation. But if only few of them are participating, then we call it as a partial. So there are two here, full participation and partial participation. Again, these two concepts become very, very important when you want to map a relational model into a relational model. To summarize, we require modeling to know the data requirements of an application in a given application domain. And then modeling is all about set of concepts that help you describe the data. And the important concepts in relational model are entity, relation, attributes, coordinate ratio, and participation constant. So we shall see how you can use different symbolic notations to graphically depict the above five, six concepts or five concepts of ER model. So first thing is entity. So entity is represented as a rectangular box. So I'll show you through a symbol here. So entity is depicted through a rectangular box like this. So if you have a student as an entity, you would write in capital letters student. So we normally use singular here. An entity normally comes as a set. So whenever I say entity type, we are referring to set of entities in the set. For example, this represents all students of a institute. Okay. Similarly, entities again can be of two types, weak entity and strong entity. So what I described just now is a symbol for strong entity. If you want to represent a weak entity, then you should use double bordered rectangle. That is a rectangle within another rectangle, just like that. So for example, student and parents, they are related, and parent is a weak entity. Now, what is a weak entity? What is strong entity? We shall see later. But for now, there are two types of symbols, one for weak entity, another for strong entity. Okay. So this is a symbol for entity. Now comes the relationship type where we use a diamond symbol for a relationship. So this is a symbol for relation type where the corners of the relation are connected to the entities. So relation is normally given a meaningful name. For example, uh, parents of students or works for the department. So meaningful name have to be given. So relation names have to be chosen appropriately. Again, we shall see how all this can be done. And on this side, you will have one entity. This side, we have another entity. It is possible that more than two also may be connected, or you may have just one. All right. So again, relations types can be three types: unary, wherein only one entity is involved; binary, where two entities are participating in the relation; and then in the third part, it is ternary, where three entities are participating in the relationship. Okay. Then we have symbols for the attributes. So we use oval symbols to depict the attributes. So this is a symbol for the attribute. For example, the student USN is an attribute. All right. Then student first name could be another attribute. And if it is an attribute which will help you uniquely identify an entity in a set, then it will be with an underline. So this is called as key attribute. And if you do not have any such thing, this is called as a simple attribute. And if you have multi-valued attributes, whereas attribute can take on more than one value, then we have a different symbol for that. So we have oval and another oval inside. So oval within oval is your multi-valued attribute. This line has to be very close to the border as much as possible. For example, the qualification of a faculty is a multi-valued, because a faculty could be a BE graduate, it could be BE MTech and also BE MTech PhD. So this attribute can take on three values at the same time. That is why it is multi-valued. And if you know the date of birth, I can always know the age of the person. So in that case, it is a derived attribute and it is a dotted oval. So age can be computed from date of birth. So this is a derived attribute. Okay. So you have a key attribute, you have simple attribute, you have multi-valued attribute, you have derived attribute, and composite attribute is a bunch of attributes forming another attribute. So for example, you have address. This could be made up of three separate components. For example, street name, city, and zip code. All right. So this is a composite attribute. And then comes complex attribute, where it could be a combination of derived attribute, multi-valued attribute, and composite attribute all in one. So that is a rare case, and we shall see later how all of this can be modeled. So you understood, what are the attributes and what are the different types of attributes that are used in ER model. Of course, cardinality ratio and participation constraint we shall see through a concrete example. So let's take an example of an academic institute. All right. So before you start modeling, always think of what is the purpose of building an ER model for this. Probably you want to record the student attendance, you want to record the student marks, and you want to prepare a performance report and pass it on to the parents. So depending on the requirement of the application, you have to model the uh, application using ER notation. So here, which are the important entities that you must take care while designing a ER model for an academic institute? So first list down all the entities. As you can see, there will be a student entity. So student is one important entity. Second is students belong to a department. So department will be a second entity. The third one could be the faculty who is teaching a particular subject. Then comes the courses which student subject, let's call subjects which the students study. Then you might have IA marks and attendance. And in this, when you want to communicate with the parents, so you could have parent as one other entity. Of course, you can include the college as another entity, and each college may have different departments. So you need to finalize on important entities in the application, and accordingly you must start visualizing the entity relations diagram. Now let's see how I can model this. So you need to draw rectangular boxes. Okay. Then next thing is you want to add, as you know, the immediate one that comes to your mind is department. So we'll have a department. Then comes the faculty. So draw the entities first and draw those which are related very close to each other. So uh, parents are related to students, so I will draw it here. Then students all have to enroll for the subjects. And you want to record the marks and attendance. So let's leave apart that college part and so on. So as you can see, we have a couple of entities here. As we know that from our experience that student is related to department. So you can put a diamond symbol here, and you can give a relation name belongs to, or in short just b underscore 2. Similarly, faculty is also related to the department. You can write works for. All right. Then student and parent, they are related, son or daughter of or ward of. Then students and subjects related, enrolled for. Similarly, faculty and subjects are related, engaged by. All right. And then this marks also belong to the student and the subject in which he is taking part. And similarly, the attendance of the student in the subject and the marks are related. So roughly we have a diagram here which depicts which are the entities and how are they related to one another. And we can go on adding the attributes now. As you can see, this has a unique attribute, university serial number. Then you have first name, last name, maybe gender here, semester, and admission year, etc. So you can just go on adding as many as you want. So that depends on the application context. So here parent name, then relation, how that parent is related to student, whether it's mother or father or cousin, whatever. Then their address. This is required to communicate to the parents the performance. So here city, house number and zip code all will come. All right. Then every subject will have a subject code, and subject code is unique. Underline subject name, then type of subject, whether it is a core subject or the elective subject. So you mention it as type. All right. Then faculty normally is given a faculty ID as a unique attribute. Faculty name. Qualification, we know it is multi-valued qualification. Then date of joining. Then date of birth. Then maybe gender. One important attribute we have missed, that is salary. As you can see, some attributes are applicable to faculty and some are applicable to students. Similarly, department will have a department number, which is a unique number, department name, possibly department location, then budget. As you can see, I have only included the attributes which are describing individual entities. Like department is described by only by these two. Here I am not going to include the HOD name or something. That will come through the relationship later. Similarly, the marks part is there could be three tests, M1, M2, M3. And once you know these marks, you can always derive the average, which is average of best two. Then attendance will be on a particular date, then time, then a room where he attended the class, and then the status, whether he was present or absent. Okay, so roughly we can draw a diagram like this, and before we move on to further, we need to complete this diagram, which is not complete unless you mark the coordinated ratio. So as you can see, many students belong to one department, correct? And here also many faculty belong to one department. All right, and then one parent may have many students. It may two of their kids may be studying there, or normally it is one to one, but in general case it is one to many. Now student and subject, this is going to be many to many. That is because one student enrolls for many subjects, and in the same subject many have enrolled, so it's going to be many to many. All right. Similarly, the student and marks will be one to many. So also one to many here. All right. And coming to the participation constant, as you know, all students have to belong to one or the other department, right? And all department must have students. So all here. Then all students must enroll for the courses. But for some courses, you might not have any students. For example, some electives are there, there are no students. So it is going to be partial here. So don't put a double line. Similarly, all marks have to belong to some or the other student. So it is going to be full participation here. Every parent will have a ward and all students will have a parent. Similarly, all faculty have to belong to one or the other department, and every department will have faculty full here. All right. So as you can see, the diagram becomes very clumsy when you have very small space to make use of. I can enlarge it a bit and then show you that this is going to be a ER model for the given application. Okay, so it is a graphical notation to depict in the given application scenario what all data entities are there and how are they related to one another. And we have described each entity with their attribute and marked some of their attributes as key attributes. Now, as I mentioned earlier, that there is something called as a weak entity. Now, if you observe, the parent entity does not have a key attribute. That is, no attribute will uniquely identify a parent. If you are storing the parent name, two parent names could be exactly same. So you can mark this as a weak entity with double bordered rectangle. So also the marks belong to the students. So this is also weak entity type. So also the attendance. If you see M1, M2, M3, they may be exactly same for a particular two different students. So in that case, it's going to be explicitly dependent on the student and the subject in which he has scored some numbers. Say also the attendance. All others are strong entity types. Hope I have explained to you what is a model, why modeling is required, and what are the important concepts in ER model. And as we discussed, entity is an important concept which refers to anything which is conceptual or real and has unique identity. Then we looked at the relationship between entities. Normally, in a given application scenario, entities don't exist in isolation. They are related very closely to each other, and hence we need to connect the entities in the given application using a diamond symbol. So, and also when you mention about strong entities, you must have the key attribute for them. If you do not find a key attribute for a given entity, you should depict that as a weak entity with a double bordered rectangle. And also you must show the cardinality ratio and participation constraint between the entities. For example, many students belong to one department and all students have to belong to one or the other department. Similarly, every department should have a student. Okay. Now, there could be other relationship in the diagram which you might have missed out. That will come through when you interact with the stakeholders, namely the people who are going to use this software. So they will tell you that something is missing. For example, in the department table and the faculty, if I want to know who is the head of the department, so there should be one more relationship here. Just a minute, I'll make room for this. I can erase this part. Just to illustrate that there could be more than one relationship between two entity types. As you can see, all faculty work for the department, but there will be one person managing each department. So HOD off. So this is going to be a cardinality ratio 1:1. And the participation constant would be full here because every department has to have a head. And however, on the faculty side, it is partial because not all faculty will become HODs. So as you can see, through proper deliberation and discussion and interacting with the end customers, anything which is missing could be added later. All right. So modeling is very, very important, and students who are in their learning stage have to get your concepts very, very clear before you move on to build ER models for any other application scenario. So you must always learn how to build an ER model for a given application scenario. So before you leave this part, you just see whether you have completed everything. For example, I have left out faculty and subject. So normally one faculty takes more than one subject, so it's going to be one to many, right? So every faculty has to take at least one ER model. So there will be an experienced person will be certifying as it is complete, as complete. All right. So as you can see, the diagram becomes very clumsy and you have a lot of problems, adjusting the attributes, moving here and there. So it's not advisable to draw ER model manually like this. Initial stages for a small application like this is fine, but I would suggest you to use a modeling tool called dia. So as you can see in this diagram, in this tool, it's got a dia tool which you can download and install. Once you install and run, you get a interface like this. So before you start, you can go to page setup and set the scale to 135 and put it in the landscape mode so that you have wider area to work with. And here you have options to get symbols for various models, UML model, database model, then flowchart and all that. So you must select ER so that you get only ER model symbols here. So if I want to use this tool, I just have to click and drag the entity, and you can copy paste as many times as you want. So I have 4 or 5 entities. I will put them appropriately. As you can see, I can move these entities easily and place them wherever I want. I can just remove this so that your diagrams will be neat and clean. And since it is an iterative process, it is very helpful to use this tool to build your ER model. So here I can include the college also. College is an entity. Then we have department. Then you have student. So you simply have to double click on the rectangular box to get the properties of it. Then here you can have faculty. This is a subject. You can say apply or just OK. This is your parent. Now parent, we know it is a weak entity type. You just say yes here so that it appears with a double bordered thing here. Similarly, we require 2 more, marks and attendance, which are weak entity types. So you place marks here. Then place attendance here. Okay. Now you use the relationships to connect them. So as you can see, the students belong to, and coordinate ratio left hand side is many and right hand side is 1. And if I say apply, as you can see the diagram comes up here, and use this line to connect student to the relationship and this relations to department. And you can move around and you can see automatically the lines get aligned and you get a nice diagram here. That's the advantage of using this one. Then I can connect departments of the given college. So one college may have many departments, and if you want this one to many appear vertically, then you say rotate so that you get those symbols correctly located. So college is connected to the department. If you want to connect this here, a little bit of adjustment you have to do and then keep it like that. Now faculty and department, they are connected. So you take one more relationship here, works for. As you can see, you can write a meaningful name to the relationship instead of just writing WFOR. So here again, coordinate ratio, many faculty work for one department. Department being on the top side, it will be 1, and you say rotate. So you get the symbols and the coordinate ratio correctly aligned. You connect the faculty here, then you connect the department here. All right. Then faculty and subject, you can say engages. One faculty engages more than one, so one to many here, and we want it left right, so horizontally. So this is how it is. Then you can connect this one here, this one here. All right. Then student and parent of, and there will be many, and parents had one. Again, you can rotate. Yeah, that's right. So you can again move these things appropriately so that you have enough space to connect them. So using a tool, as you can see, is very easy, and you come up with a nice looking ER model, and it is easy to connect all of them. Now student enroll for the course. So this is going to be many to many. So I would write many here, and I would put them vertically. So student and subject, they are many to many like this. You can pluck it and place it here so that you can pull it down like that. Then attendance, and this you can take a little bit here. Again, attendance is connected to, you can take one more relationship here, marks off. So again, one student may have many marks. So student is connected to marks, and marks connected to marks. And to know in which subject he has scored, this also must be connected. Same is true of attendance. So we'll remove this for simplicity, and then we can go on adding attributes. So I take one attribute here, USN, and it is a key attribute. We know it's underlined, so say apply. As you can see, it's a oval shape with USN underlined. Then comes your first name, last name, and so on. Then possibly semester, which semester is studying, and so on, gender, etc. So you can add them. And to connect attribute to the entities, use this tool from the toolbox, or the line component from this. This is how you can connect. Similarly, if you want to describe the department, you say department number here, and it is a key attribute. Yes. Then we have line connecting it. So other attributes you can just go on adding, like you can add a department name, you can say rename. It's a simple attribute, so nothing is to be modified. You connect like that. All right. Then faculty, we have a faculty ID, faculty name. It's a key attribute. Then you can just copy and paste, but the problem is paste comes here. You have to bring it down, and F name is not a key attribute. We have to undo this. Okay. Then use this line to connect. See that the red color highlights appear when you connect them, so that the connection is complete. So we have subject code as key attribute. It's a key attribute here. Subject name as another attribute. It's a normal attribute. Then type and all that, so you can just go on adding. So for demonstration purpose, I'm not adding all. I'm giving you a simple way to complete it. I'm just showing by adding minimal attributes. So parents will have a parent name. As you can see, two parents could have exactly same name. That is why it is a weak key, right? So it will appear with a dotted underline there. So cannot be a real key attribute, parent name and like that. And for marks, you can have M1, first test marks, M2, and so on. So you can just copy, paste, make that M1, M2, M3. Double click, change it to M2, apply. Double click, M3, apply. Okay, and then you connect these. Then connect this one. So just want to show you how you can add a derived attribute, like the average of three tests is a derived attribute. Just click on derived yes here, and then you see that oval shape will be dotted oval. That means it can be derived from these two. You need not store this average value. Similarly, if you want a multi-value attributes, for example, faculty has qualification. It is multi-value, so multi-value if you make true, so it becomes a double bordered oval shape, and you connect like that. Can enlarge a little bit. I think so. It will not connect properly. Yeah. All right. So we have and participation constraint. For example, all students have to belong to one of the departments. So here it said total. You'll get a double line. All departments should have students. So again, say apply like that. So double click the line and decide. So every faculty has to engage one of the other subjects. So it's true like that. And every college has several departments. So total here. However, all subjects are not taken by faculty. Some subjects could be elective where no enrollments might have happened. And now that this line is shifted here, you can put it properly. You have to just move like that to get the lines properly connected. And full participation, full. All faculty have to belong to one or the other department. Yes, here every department has to have faculty. Yes, here all students should have marks. All students must have parents. Yes, all parents must have their kids there. Okay. So this is more or less complete. And if you want to add a label to this to describe what it is, you can say ER model for institute management, right? Then say designed by and write your name. Then date, which date you designed it. Let's say 25/6/2025. So it's a nice diagram, and you can color them, like if you want a colored line color here, you can choose like that. So it looks little more impressive now. So you have a choice to select whichever line that you want. Accordingly, the diagram start changing its color. Use appropriate color to mark them. However, choose some bright colors, otherwise they are not visible. Then parents, here also can add some color. Okay, forgot to connect the parent name to entity. Yeah, so you can just go on and modify the colors of these things so that you got a nice looking ER model. Even the attributes can be colored like that. So first name be red, and then semester could be some blue color. So as you can see, you can get a nice looking ER model, and you got to save it, and so that you can take a printout of this. All right. So to get to this level of complete ER model, you must have very good domain knowledge. When I say domain knowledge, the way departments or institutes function, how the hierarchy is, where they have college have different departments. Every department has faculty and students and are related to the department, and their marks and attendance are all recorded and monitored. Of course, I forgot to connect the department and faculty through head of, so you can add that head of department. Again, coordinate ratio will be 1:1. You can mark it vertically and just like that, and connect the department head to faculty, because faculty only will be department head. So you must mark them like that. Okay, the head of. So this also can be put in a different color so that it looks good. So work for and head of, they are two relationship uh, connected with the department and faculty. So this is a more or less complete ER model. So friends, today what we saw is how to get a visual view of the data in a given application domain through ER notations. So in ER model, we have a rectangle for entity, we have oval shape for attributes, we have diamond symbol for relationship, and in attributes again we have oval shapes which are dotted for derived, for double bordered, for multi-value, and if the attribute is key attribute, the attribute name will be underlined. And again we have participation constraints which are of type m is to n, 1 is to n, 1:1, and so on. And we should be marking all these things properly and adding all the attributes. I have not added all the attributes just for keeping it simple, so that you can go back, work on this and complete it, so that the entire ER model captures all the attributes of the entities and it is complete in all respects. All right. So thank you all for watching this video, and I'll see you in the next video.